Today we're going to talk about molar heat capacity. So, molar heat capacity is an equation to determine how much heat you need to do in order to reach a certain temperature. How much heat you need to apply in order to reach certain temperature. So let's try this problem. How much heat energy in joules is required to heat up 5 mole of water from 20 degrees Celsius to 50 degrees Celsius? And we have a given molar heat capacity of water. So that's going to be 75.95 joules for moles times Kelvin, Celsius, not Kelvin. And we have the change in temperature. That's going to be 50 degrees minus 20 degrees. So that's 30 degrees. So the energy required to heat 5 moles of water from 20 to 50 is going to be 11,392.5 joules. So that's a lot. Now let's try this one. It takes 8,860 joules of heat energy to raise the temperature of 8 moles of substance from 25 degrees Celsius to 70 degrees Celsius. So what we're going to do here is calculate the molar capacity of this substance. We all know that equation is going to be Q is equal to N cat. And we're going to solve for C. So we can just use simple algebraic manipulation here. So our molar heat capacity here for this substance is going to be 8,860 divided by 8 times 45. So we can just plug in this into our calculator. It's going to be 24.6 joules per mole times Celsius. So that's it. Now let's try a little more complex problem. Let's say you have 2 moles of metal at 150 degrees Celsius. It is added to 10 moles of water at 20 degrees Celsius. The final temperature of the mixture is 26 degrees Celsius. So we're going to calculate the molar heat capacity of the metal. You also have given the molar heat capacity of water. So to do this, what we're going to do is just to set them equal because it will reach a thermal equilibrium. What we're going to do is put a negative at one of the equation. Let's put in on the metal, and then we can just solve for the molar capacity, heat capacity of the metal. So we can just plug in what we had given, the moles of metal and the temperature. It's going to be 26 minus 150, and we have here 10 moles. We also have the molar heat capacity of water, and we have the change in temperature of 26 minus 20. That's going to be 6 degrees. Let's just write it. And now we can just use we can just divide both this by 2 and around 26 minus 150. So the molar heat capacity of this metal is around 18.25 joules per mole times degree Celsius.